As students begin to build their project idea, they generate drawings that can take a variety of forms.
When they have their artistic drawing, I'll have them create some basic drawings from there and then prototype a few components.
This is the crankshaft, work in progress. We still gotta take a lot of material off. That's the hardest part, trying to get something off center, accurate, within 1/1000 of an inch.
Even without an engineering department to draft blueprints, manufacturing students have workarounds to create the drawings they need to begin their prototypes.
Like, we could even take this part on Google Images and we could just throw it on there, trace it all out, and then when we're done, we can delete the picture and it'll all be there, and then all we have to do is just adjust the sizes and everything.
We've created these prints and also 3D models to help explain to everyone what exactly they're making so everyone's on the same page. Because the prints are always changing and we're writing them out by hand, there's a lot of crossing out and fixing and that sort of thing. Like, I'm going around, or any of the other designers are making sure that everyone's doing the most current updated print instead of making something that we changed yesterday.
Some schools have the benefit of an engineering department.
The CAD students engineered the part, came up with drawings, created prototypes with their rapid prototype machine, and looked at interactions right away, whether or not it could be made or not.
We have a 3D plotter, so we plotted some prototypes to get kind of an idea of how the whole thing went together.
It was a lot easier to 3D print a prototype and get a better idea of what it's going to look like instead of just having it on your computer. So that was a good idea.
But the tolerances are limited on that. It's not quite as good as actually manufacturing the part and seeing if they're really going to fit.
This one, for some reason, went too small.
Well, the thing, like, we don't really have any tolerances, so
I know, but it's just, like, it was way off.
Okay.
So...
Yeah, that's fine. I mean, either way, like, we have some stuff we have to work on anyways.
Yeah.
I assembled the entire class and I had them elect a foreman so that they can work with the foreman from the CAD department.
It's a big responsibility on my shoulders because managing like 19 people is kind of, I wouldn't say it's a big deal, but it's pretty important.
So if a student that's working on a particular project has a question, instead of coming to the instructor, they can go to the foreman. The foreman is more or less the point guard, if you will, and it's going to be walking back and forth between shops and create that dialogue.
And I think being able to manage the whole project, it's a big responsibility, but it gets you ready for like having to deal with real world problems, stuff like that. So that definitely builds a lot of communication skills. Because we got to communicate with each other and figure out what part's working and what part's not working. So yeah, that was a cool part of the project.
Or do you have a copy of this? Or mark down some information, because I'm going to take this back to make the changes, just so you know.
Obviously, we're down here, and they're on the other side of the school, so they don't see what these machines can actually do.
We had a group meeting with both classes, and we talked about communication skills is extremely important in the real world, that there's a good way of communicating and a bad way of communicating. So we kind of set the ground rules with respect to that.
There is really no way to know unless you talk. Yeah, this center hole right here that's 1.125 in diameter.
So it'll hold this. I just need the location, the Y location of these 4 holes.
Okay.
Meanwhile, for schools that work entirely within one advanced manufacturing department, the students may get into machining prototype parts right away.
While they start their sketching processes, the machinists on each team actually have to start cutting stock, start roughing out the prototypes and coming up with the initial parts.
We're just starting like actually machining everything, so it's kind of fun to see everything like slowly coming together. We're doing kind of like a prototype pieces first to make sure the whole thing works, rather than build the whole thing out of the correct materials and then find out later that it doesn't actually function.
So what I'm making is the part that holds the blades inside of the housing. The prototype is going to be made of nylon type of plastic, but the final part is going to be made out of titanium.
Yeah.
One of the problems could be getting the slides that's going to be trapping the air, fitting comfortably into the slots without being too loose or too snug. We want it to be just right so that they slide in and out on their own. The tolerance for the slots has to be within 1,000, which is about a human hair width.
I think we're gonna want like a 2,000th clearance in between the size of this and this.
It's a thrill for engineering and manufacturing students alike as drawings become reality.
This is the first thing that I've drawn, and it's been produced for the first time ever, so it's pretty cool. At first, I just had the flywheel as one main part, but they only had a 1/4 inch stock, or 1 1/4 inch stock, so I had to make it into 2 separate parts and make countersinks so that way they stick together.
Got it.
There it is.
Feels like we're a company trying to come up with a new machine or part for something. It's pretty fun.
No real-world lesson is as valuable as learning to face mistakes. Coming up next, we see students learn to take in stride changes, redesigns, and remanufacturing.